Welcome to implicit differentiation. So the idea here is not all equations, not all graphs of x and y are functions, and not all can be written as functions. So not all graphs or equations in x and y come in the form of a function. Sometimes y is also involved in the operation, so it's not just y equals. So for example, we will look at this one later in this video. X squared plus y squared equals 4. This is not written in the form y equals. It's not a function. This is actually the equation for the circle of radius 2 centered at the origin. So it would not pass the vertical line test. So if we want to take the derivative of this, it's not a y equals problem. So taking the derivative with respect to x is complicated, right? So this is not in the format y equals blah, 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 just in terms of x. So let's just say it's not in the format y equals f of x. Something just in terms of x on the right. And so the question becomes, how do we find y prime when y itself has operations on it? So what we are going to do is we are essentially going to use the chain rule. We will view y as a function of x. And we can differentiate anything involving y with respect to y before we differentiate with respect to x. So we will do the derivative with respect to x. We could do the derivative with respect to y, and then times the derivative of y with respect to x, or in other words, times y prime. So let's go ahead and just take a look at how this works in practice. So we're going to look at that x squared plus y squared equals 4, and we are going to use implicit differentiation to find y prime. So we are going to just go ahead and take the derivative of everything with respect to x. So let's take the derivative of both sides of the equation. With respect to x. So we'll have our equation, x squared plus y squared equals 4. And we'll do the derivative with respect to x of both sides. So by our derivative rules, we can go ahead and split this. This is like taking the derivative with respect to x of x squared plus the derivative with respect to x of y squared is equal to the derivative with respect to x of 4. And so we can easily take those two derivatives on outside the x squared and 4. We know the derivative of x squared with respect to x is just 2x. I'm going to leave the one with a y as derivative of with respect to x of y squared. And then the derivative of 4, that's the derivative of a constant, is just 0. So now what we will do is we will use the chain rule on the component comparing y. So our y is acting like what I would usually set u to be. And what we're going to get is we have 2x plus, we're going to take the derivative with respect to y of y squared. And then we are going to multiply by the derivative of y with respect to x. I put that in the dark blue instead of purple because we're not different. There's nothing to do beyond that. That's what we're actually trying to solve for. So using the chain rule, we therefore have 2x plus derivative of y squared with respect to y is 2y. And we have times dy dx. And this is all equal to 0. And now what we'll do is we will solve for dy dx. So we just use a little algebra. So I'm going to rewrite 2x plus 2y times dy dx equals 0. Using algebra, we would subtract that 2x from both sides. And we'd have 2y times dy dx is equal to negative 2x. And then we would divide by our 2y. And we'd wind up with dy dx is equal to negative 2x over 2y, or negative x over y. So we just used implicit differentiation to find the derivative of y with respect to x when we had the equation x squared plus y squared equals 4. So this is just one example of implicit differentiation. We will see more examples in future videos.